The ocean is vast. Covering approximately 70% of the Earth's surface, it holds 96% of all the water on Earth, producing 50 to 80% of the planet's oxygen and carrying 80% of all life on Earth. Not only this, but the ocean is Earth's largest carbon sink, absorbing around 50% of the world's CO2. The oceans are not only beneficial, but imperative for human existence, and the purity and function of the ocean are under threat. Plastic is killing our oceans. In 1950, there was only 2 million tons of plastic produced each year. In stark contrast, there are now 380 million tons of plastic produced every year. Scientists estimate about 8 to 11 million tons of that plastic entering the ocean every year, which is equivalent to a garbage truck a minute. Without any action, this figure is expected to triple to 29 million tons in 2040. And once that plastic enters the ocean, it stays plastic forever, breaking down into harmful microplastics. This ocean plastic threatens the environment and the animals in the ocean. There are thousands of animals, seabirds, turtles, and seals that die every year from ingesting or getting tangled in plastic. Not only this, but many animals ingest plastic nurdles, mistaking them as fish eggs. This can cause them stomach ulcers and give a false sense of fullness, leading them to starvation. A fourth of all fish species and almost 80% of albatross have plastic in their stomach. The threat of plastic doesn't stop with marine life. It climbs up the food chain all the way to humans. Plastic is in the food we eat and water we drink, and the toxins can cause issues to our respiratory, nervous, and gastrointestinal systems.
So the biggest research question still in this field is what happens to plastic in the ocean, because we don't really know what happens to 99% of all plastic. So 1% is estimated to accumulate in garbage patches in the middle of the ocean in the subtropics, so from 20 to 40 degrees latitude in every ocean. So there's 5 of those garbage patches, 2 in the Pacific, 2 in the Atlantic, and then 1 in the southern Indian Ocean. What happens in the subtropics is there's these really large gyres, so very large circulations of ocean currents. And on each side of those gyres, currents move toward each other. And because water can't pile up and form giant hills, it has to go downwards into the ocean. And because plastics float, they actually stay and float at that surface. So that's why they accumulate in garbage patches. We can use different ways to track where we think plastics might be going or where floating objects in general might be going. So we can use computer simulations to do that. So just like you have weather models for the atmosphere, we have computer models for ocean currents. And based on what the currents are doing, we can determine what might happen to plastics or any other floating object. And then the other way is using ocean surface drifters, which are GPS-tracked floating buoys. And there's this really large drifter program by NOAA, which is an institute in the US, and they have released ocean surface drifters all over the globe for several decades now. And we can use that data to kind of see what is happening to these actually floating items in the ocean. And that covers pretty much the whole globe, so we can use that to kind of figure out, okay, this might be what the plastics are doing as well. It's important to model where ocean plastic goes for a few different reasons. The first is that if we don't know where plastic is, we don't know what harm it's doing. The second is that we kind of want to know where it's coming from so we can solve this issue as well. So for example, the Cocos Keeling Islands and Christmas Island and many other islands in the Indian Ocean as well, they get a lot of plastic that's not coming from themselves but from other countries. So if we can pinpoint which countries are responsible for that, then that's a way to actually start solving this problem as well.
And hopeless as this all sounds, our generations can clean up and fix the past generation's mistakes and positively change the future. Action on a global, social, and local scale is necessary to solve ocean plastic pollution. The Ocean Cleanup is a non-profit organization that is dedicated to clean up all the plastic in the ocean, with a goal to reduce 90% of all floating ocean plastic by 2040. They achieve this goal using self-developed garbage collecting systems. Currently using System 002, the process works in 4 steps. First, they target the high plastic density areas. Then 2 ships and a U-shaped barrier in between them go at a slow forward speed to retain the plastic in the net at the end of the barrier. After the system is full, they dump the catch on board and start again. They sort and recycle the plastic that they have collected. Currently, they are developing System 03, which will be 3 times the size of System 002, and predicted to be 10 times more effective. Thinking forward, the Ocean Cleanup decided to stop the source of plastic by intercepting the pollution from river mouths. The Interceptor Original is 100% solar-powered and self-operated, working in 5 steps. Firstly, the barrier guides the river waste to pass through the system, where the conveyor belt picks up the debris and delivers it to the shuttle. The shuttle distributes the waste into 6 dumpsters, which have the capacity to hold 50 meters cubed of trash. Once full, it sends an automated message to the local operators, who then come to collect the waste. The Interceptor trash fence uses a chain-link fence that is anchored to the banks of the riverbed. It is specialized for flash flood events and was designed for highly polluted and hard-to-reach locations. The Ocean Cleanup now has 8 interceptors actively running in 5 different countries. With continued research and advancing technology, Ocean Cleanup plays a major role in solving and ending plastic pollution. Dr. Julia Reiser is a leading scientist in tackling the marine plastic pollution issue. She has worked across the board with multiple organizations for both ocean cleanup as well as environmentally friendly alternatives to plastic. In her most recent foundation, the UWA project has developed an alternative to plastic polymers using seaweed.
I had this idea of making polymers out of seaweed rather than fossil fuels or crops, but we start to use corn or sugarcane to make plastics. Then we would end up with other problems, like we use lots of fertilizers, we might have to deforest more. Seaweed is a marine crop that grows just with seawater and sunlight. Why not making PHAs out of seaweed to replace plastic at scale? So it mimics very well plastic, so it's waterproof, windproof, lightweight. At the end of its life, it can be composted. So it's truly biodegradable.
Because the UWA pellets are compatible with machines that are currently used, the scale of change is unlimited. Companies are able to keep all of their current machinery and use UWA pellets instead of plastic nurdles to produce the same things. With the right conditions, UWA can completely replace all plastic. In Australia, 3.5 million tons of plastic was used from 2018 to 2019. A third of that plastic is single-use. Unfortunately, less than 15% is recycled, and the majority goes to landfills. In 2019, less than 40% of Australia's waste was recycled, but they aim to recycle half by 2025. Australia's current recycling system is a 3-bin system: red for general waste, yellow for recycling, and green for compost and green waste. Up to 16% of the curbside recycling is sent to landfills due to the wrong waste going in the wrong bins. The world's best recycling system is in Germany, who is already recycling 56% of their waste in 2002. They sort their waste into 6 categories, which include general waste, paper, plastic, clear glass, colored glass, and compost. The key to their success is strong government action and the general public's awareness of the waste issue, working hand in hand. Australia has come a long way, but the government needs to follow Germany's lead by implementing better recycling systems, including more recycling facilities. This helps minimize plastic ending up in landfills or being shipped to other countries, like Indonesia and Malaysia, where it is likely to be mismanaged, ending up in the oceans. It is our job to recycle properly and advocate for better onshore recycling centers.
Hi, I'm Kat and I'm 10 years old and we are the Cone Hill Cub Scouts. We are helping protect the environment. We're on a rubbish pickup.
Beach cleanups are easy to find all over Australia. Keep Australia Beautiful is a body in the Western Australian government that is dedicated to litter prevention and reduction. They organize beach cleanups around several beaches in WA. Another one is called Tangaroa Blue. Tangaroa Blue is a volunteer-based charity that started in 2004.
Just care about the environment and like to give back to the community every now and again.
And we live in such a beautiful place, it's really important to keep it clean.
I found lots of plastic, lots of paper. People are doing a lot of littering.
Cigarette butts, some cans, bottles, plastic straw, plastic bits.
A lot of rope.
Since then, they have had about 30,000 cleanups across 4,000 cleanup sites with over 200,000 volunteers. They have successfully removed 2,000 tons and 21 million pieces of trash. In the past 10 minutes, you have seen the devastating present up to the hopeful future. But here's where you come in. You can make an impact on our future by starting simple. Choose the better option. Educate yourself and others about the future of plastic and advocate for the use of plastic alternatives. Recycle. Recycle the plastic that you use and purchase recycled plastic products. Attend local beach cleanups. By attending these events, you are not only helping collect the trash, but to spread awareness about how important the health of our ocean is. Hopefully, through these simple changes, the future of our oceans will be healthy and plastic-free.
Can you guys just give us a clap? Are you filming? Okay, good.